So I can speak right now, right? Hello? Okay, perfect. Hello, everyone, and welcome to our Can you see my screen all? It's opening. Yep. Okay. Our project is called DigiTech Port 2030, as I said before. The main goal is about decarbonization, the decarbonization of small and medium-sized ports in small and medium-sized ports. As we all know, ports are essential hubs and for global trade and logistics. However, nowadays they are facing a lot of problems and challenges, such as the pressure from the European Union to reduce their carbon footprint and comply with the European Green Deal package and Fit for 55 packages. Thus, DigiTech Port is designed to address these issues and provide innovative solutions to solve these issues and provide some methodologies, some interesting solutions in order to decarbonize and in order to help small and medium-sized ports. Okay. Right now, I would like to present some general information about our project. So the project started on September 15, 2023, and will last till September 14, 2026. The project is sponsored by, the total budget of our project is 1.6 million euros. And it's also co-financed by European Regional Development Fund. The project is also founded on the ground of the previous projects, such as Connect to Small Ports and DK 2030, which provided us a nice perspective and nice knowledge and research for doing this current project. And we have several goals, which I would like to describe as well. First of all, we try to support, of course, small and medium-sized ports with knowledge, with methodologies, with some strategic solutions in terms of the green transition and decarbonization. Second goal, of course, is to equip small and medium-sized ports with the knowledge in their green transition and decarbonization. And last but not least, we are trying to test and implement two main pilots and two main solutions, which will solve as a practical tool, practical showcase of our project. And the first solution is called Green Energy Harmonization Toolbox for small and medium-sized ports. First of all, we are analyzing different technologies, different solutions which are currently available in the maritime sector. We also will provide innovative methodology, innovative solutions for our project, and we'll merge it in a common solutions, in a common toolbox. And as a practical tool, we will develop a green compass, which will serve as a green compass tool, which will be representing as a practical practical solution for green transition in small and medium-sized ports. Thus, we believe that these technological advancements and these technological solutions will help small and medium-sized ports to successfully implement decarbonization and green transition. Our next solution is devoted to EU regulation and green policy compliance roadmap. Here I would like to say that despite the fact that we need to develop some technological solutions, as I said previously, ports need to not navigate also in a complicated regulations, complicated laws, which are available in the maritime sector nowadays in the European Union. Thus, this compliance roadmap will focus on simplification and analysis of current laws and regulations, and will provide a comprehensive methodology, comprehensive tool in terms of the policies and initiatives introduced by the European Union. Second of all, it will provide it will identify and will analyze the methodologies currently available in the maritime sector and introduced by decarbonization targets. And as a result, we will develop fact sheets and different visual tools which will be tackling the issues of issues of the roadmap as well. And thus we believe that this roadmap will help to identify core solutions of the legislation and will help small and medium-sized ports to better understand all of the legal issues in the sustainability sector. The next, what I would like to discuss is the first pilot which we're implementing, which is called Energy Twin. Energy Twin is a next step of a digital twin, and it's an innovative solution, innovative technology which helps to analyze current systems of integration and data flows. It also analyzes all energy flows in the port sector, and it also integrates the energy demands and supply with distribution of green energy. As a result, we believe that Energy Twin is a very nice, very important technology, which will help ports to reduce their carbon footprints, of course, which will reduce the emissions and which will optimize operational cost. The next pilot which we will be implementing is devoted to port electrification. As we all know, nowadays many small and medium-sized ports still using diesel-powered equipment, which causes a lot of air pollution and a lot of carbon footprint. Thus, we are trying to implement three main solutions in this pilot. First of all, we will try to fully electrify the forklift in Euroterminal in Świnoujście in Poland. The second of all, we will be oriented and focusing on shifting from fuel-based vehicles to electrified counterparts in the port of Elbląg in Poland as well. And we will be also modulate and transfer to renewable energy at the port of Stralsund as well. Thus, we believe that by port electrification, carbon footprint will be also reduced and air pollution will be also reduced, and it will help small and medium-sized ports as well to transfer more successfully, more effectively to sustainability and green future. Okay, now I would like to talk about our target groups in this project. First of all, of course, we are oriented on port authorities and ports and maritime organizations. These authorities are directly implemented and participate in daily operations and daily logistical issues in the ports. Second of all, we are having as a target group science and technology parks, different universities, different maritime schools, which promote technologies and innovations in the maritime sector. Of course, we are also focusing on EU policymakers and politicians, which are trying to which focus on the regulations in the maritime sector and sometimes provide us with an available knowledge in terms of the laws which exist in the maritime sector. Yeah. Following this, I would like to describe our partnership in a nutshell. We are having 8 partners from 4 different countries, and you can see on the map how they are spread in the map. As I said, I'm from Hochschule Wismar, University of Applied Science in Germany. Then we are having the Klaipėda Science and Technology part from Lithuania. We also have communication leaders in the face of Motors Foundation from Poland, Blekinge Institute of Technology from Sweden, which promotes different innovations and different technologies in our project. We have Maritime University of Szczecin from Poland, which also implements various technologies, various prosperous solutions in our project, and working hard on the toolbox, which I mentioned before, and different other solutions. We also have Elbląg Seaport Authority, which is also a very important part of our project. As I said, they are participating in port electrification pilot. Next, we're having Klaipėda State Seaport Authority, which are also participating in the pilot, where we need their support and help in one of our work packages. And last but not least, we also have in our cohort, in our community, Euroterminal Świnoujście from Poland, and they're also working hard in terms of implementing the energy pilot, and port electrification. Now I would like to discuss about funding of our project. So our project is funded by Interreg South Baltic Program 2021-2027. And this fund is oriented on cross-border cooperation between 5 different countries and promotes sustainability and green transition as well. Here we include several countries included here. It's Germany, Lithuania, Denmark, Sweden, and Poland. And the total budget of this program is 83 million euros. And it is very important to be in this program since we're developing innovative solutions, and we try to be more sustainable and green. Yeah. On the next slide, you can see our additional research, which is devoted to questionnaire, which we address to ports and port authorities to complete. And here, in this research, port authorities can help us to identify and show how they see themselves in terms of digitalization and green transition. And by providing us this additional information, we can identify how ports see themselves nowadays in the digitalization. You can scan the code and complete the questionnaire, which will help us a lot in the research. And the second research which we implement at the moment is devoted to it's connected to the previous one, but it answers the question: if the port sees themselves as a digital one, how the port sees themselves as a green? Do they believe that they're green enough in the maritime sector at the moment? This questionnaire consists of additional 5-6 questions, and helps us also to have more information and more inputs on our digital map, which we are implementing at the moment. And last but not least, I would like to introduce you to our website, official website, and LinkedIn. You can also scan the QR codes and join our project, and follow us, and have all of the updates, all of the inputs which we are introducing at the moment. And yeah, thank you very much for your attention. And if you have any questions, I'm open for addressing them. And yeah, thank you very much. My question is, does anyone have any questions at the moment? Okay. Then I would like to give the word to Professor Stefan Jankowski and to Professor Marcin Przywarty, and they will be telling about Toolbox, Green Toolbox, and decarbonization of small and medium-sized ports by digitalization. The floor is yours. Please go ahead.
Okay, good morning, everyone. Good morning, ladies and gentlemen. Greetings from Szczecin, Poland. My name is Stefan Jankowski, and could you confirm me that you see my shared screen about the presentation? Hello? I am visible?
We can see it and we can hear you.
Great, thank you. Okay, so as Lisa mentioned about the toolbox, and one of the tool is the compass, and the compass has one of the most important, let's say, role which play the regulations. And today I will talk about the IMO legal frameworks and compliances. So the plan for the presentation is as follows. So we talk about the MARPOL conventions. The MARPOL conventions was of the most important convention in the shipping about the pollutions at the water, and 5 of them concern the water pollution. So we will go through them very fast, and then we stop a little longer for the Annex 6, which concerns the air pollutions. We mentioned about the Paris Memorandum of Understanding, which is a very strong tool to enforce compliances with these regulations. And also we mentioned the IMO greenhouses gases reduction strategy. Okay, International Maritime Organization is one of the regulators which has the most, which governs the most activities on the sea, so mostly the shippings, and therefore in 1973 adopted the international conventions of the prevention pollutions from ships. In short, we call it MARPOL. And as I mentioned, it's the 6th annex, but the first 5 was established at the very beginning, 1973. So the first one concerns regulations for the preventions of pollution by oil. The second concerns the pollutions by noxious liquid in substances in bulk. Then we have regulations concern the pollutions by harmful substances carried by sea in packaged form, and Annex 4 concerns the preventions of pollution by sewage from ships. 5 Annex regulation for the control of pollutions by the garbage from ships, and finally the 6th is the regulations for the preventions of the air pollutions from ships. And it was established and adopted in 1997. And the first regulations regarding such a pollution is Regulation 12, so ozone depleting substances. And this regulation concerns of vessels 400 gross tonnage and more. And it says that all vessels constructed after the May 205, all installations contain ozone depleting substances should use these hydrochlorofluorocarbons needs to be used. Other are prohibited. So mostly these regulations concern the cooling systems. And after 2020, in such a systems can be used only the ozone-friendly substances. But meanwhile, also there are still the old vessels which are using this hydro and so on. So which are allowed after the 2005. So for such a vessels starting from the 1st October 2025, the record book should be provided. And this record book, which should be approved by the flag administrations, should contain information in terms of quantity in kilograms concerning such a situations listed below. The next regulations, Regulation 13, concerns the nitrogen oxides, and this regulations applies to each vessel, actually to engines on the vessels, which the power output is more than 130 kilowatts. And here we have three distinguished cases. Two of them concerns engines and one areas. So we call it tire. Tire 1 concerns the emissions limits of nitrogen from the engine on the ships constructed after 1st January 2000, but before 1st January of 2011. Tire 2 concerns the ships constructed after the 1st January 2011. And the Tire 3, as we said before, concerns the areas. We have 4 special areas. One of them is the Baltic Sea, where are the emissions much more reduced, needs to be much more reduced. And there are the numbers. So we have 3 kinds of engines. They are divided taking into account the revolutions of the crankshafts. So revolutions per minute. So we have the engines which with revolutions less than 130, then revolutions between 130 to 2000 and more than 2000. And here we have the grams of nitrogen oxides per each kilowatts hour. And this is how the curve looks like based on the middle column from the previous slide. So just to show that the left side, how we need to go to the right side for the revolutions over 2000 revolutions per minute. Of course, all engines installed on vessels needs to have a certification for such a nitrogen oxides emissions, and this methodology and certifications needs to be let's say established based on the revised NOx technical code from 2008. Next regulation is regulations 14, sulfur oxides and particle matters. Actually, we have talking about sulfur oxides, but the regulations concern the content of sulfur in the fuel oil. So nowadays we have the limits decimal 5% of mass worldwide, but we have also here the emission control areas where the limits cannot exceed decimal 1% of mass, the sulfur in the fuel oil, which is used or carried for use on board a ship. And we have 5 such a special area. Baltic is one of them. The next regulations concern the volatile organic compound. This is the regulations for tanker. It's not the emissions from the engines, from the burning fuel, but let's say kind of, it's not really, but kind of vaporization of crude oil or other hydrocarbons liquids. And then we have regulation 16 about the shipboard incineration. So these regulations describe the technical requirements for shipboard incineration and also what kind of substances can be burned. Actually, we have below the list which show us the prohibited substances. What kind of substances cannot be burned, incinerated on the ship. And because not all can be incinerated, burned or discharged to the water, to the atmosphere, the 17 regulations is about reception facilities. So actually this concerns the ports. So those pollutions which cannot be discharged or burned on the ships needs to be received by the port facilities. And here we have actually two kinds of such pollutions. So this mentioned it before, ozone depleting substances, so from the cooling systems. And the second is the pollution or the residues from the exhaust gas cleaning systems. So, for example, scrubbers. And then we have chapter 4 of this Annex 6, so the regulations on the carbon intensity. One of them, so we have regulations 22 and 24, which regard the energy efficiency design index. And these two regulations concern new ships. And the followed formula has to be fulfilled. Okay, there is also the information that vessels constructed after the 1st January 2022 need to report attained and also required energy efficiency design index by electronic communications. And this energy efficiency design index needs to meet this formula, so attained EEDI needs to be less or maximum equal to the required EEDI. And after the sign equals, we have the formulas how we can calculate this required EEDI. So we have two parameters, X, which is the reduction factor, and then we have the reference line value. Both of them can be calculated by using another formulas and also some information from the tables which are also in this chapter and in these regulations. And for this energy efficiency design index, we have 4 phases. And now we have the phase 3, which started from January 2025. And as I mentioned, the reduction factors for the EEDI is calculated, depends on the ship types and the size of the ship. And here we have the values for it. For it depends on the also particular phase. And the reference line value is calculated using 3 parameters ABC, which are also depend on the ship size and types. And here we have few rows from the table which show us some example of the value for these parameters. Then we have regulations 23 and 25. And these regulations concern energy efficiency existing ship index. So for, let's say, older ships, not new one. And this also needs to meet this formula. So attained EEXI needs to be less than required EEXY, XI, which we calculate using very similar formula, but here we have the reduction factor Y, which also depends on the ship type and ship size, and we then multiply the previous energy efficiency design index reference line by this reduction factor. The regulations 26 is about ship energy efficiency management plan. So all ships needs to have such a plan. So which describe the annual operational carbon intensity indicator, which is specified in regulations 28. I will mention about this on the next slides. So for the next 3 years should be mentioned, and also the implementation plan documenting how the required annual operations carbon intensity indicator will be achieved during the next 3 years, and also a procedure for self-evaluations and improvement. And this is for the vessels, particular vessels. And regulations 28, so operational carbon intensity indicator. So the regulations is for the ships of 5,000 gross tonnage and more. And here we have the formula which can be used to calculate the required annual operational carbon intensity indicator. Here we have also two parameters, Z, which is the annual reduction factor to ensure continuous improvement of the ship's operational carbon intensity, and the reference value, so as a CII with the index R. And also we have the information that these two parameters needs to be developed by the organization, which means International Maritime Organization. And also will be provided a review by 1st January 2026 by the organizations to assess the effectiveness of these regulations, need to reinforce corrective, especially for the existing ships energy efficiency index, the need for the enhancement for the enforcement mechanism, the need for the enhancements of the data collection system, and the revision of the values for the Z factor and the reference value of carbon intensity indicator. And finally, we have chapter 5, the last one in the Annex 6. And this chapter is about verifications of compliance with the provision of this annex. And for the implementations should be used the IMO Instruments Implementation Code. This is the resolution A1070. And also the information here is that each party, so each state, actually the flag state, the ships, shall subject the period audit made by organizations, so IMO. And when we are talking about this implementation code, the implementation code describes obligations for 3 kinds of countries, so flag states, so where the vessel is registered, coastal states, so the territorial waters are used by the vessels, and port states, so it means the states, the countries in which ports the vessel berthing or discharging, loading, and so on. And then we have so we have to back a little bit to the chapter 2, the annex number 6, the regulation 10, which described the rights of the port states control in view of this annex 6. And this is very powerful, let's say, tool, because as you can see here in the bold, we have the ship party. It means the states or the ports authority shall take steps to ensure that the ship shall not sail until the situation has been brought to order in accordance with these requirements. So this is very powerful, that the vessels can be stopped and cannot leave the port because some deficiencies. And to make these inspections even stronger, we have some agreement. So the agreement, regional agreements between the port state control, we call it Port State Control Memorandum of Understanding. And in Europe, we have the Paris Memorandum. And the current member states are mostly all of the European countries, but also Iceland, and in case of Russian Federation is currently suspended. And these countries coordinate efforts to inspect foraging ships entering their ports. And there is very powerful tools because we have, let's say, a list. So this memorandum categorized vessels by risk profile. So we have high-risk ships, which are inspected more frequently, and lower. So we will have them listed on actually 3 lists. And if deficiencies are found, they must be corrected before the ship can continue operations. So if the deficiencies are found out by the inspectors, all operations of the ships are stopped and then can be continued after solve these deficiencies. And if ships has serious safety, environmental or labor violations, it can be detained until all these issues are resolved. So it, let's say, generate a lot of cost for the ship owner or charterers if such a situation have place. And repeated offenses can lead to banning from Paris Memorandum ports, which simply means that such a vessels cannot enter this port of the country of Paris Memorandum. And here we have this 3 lists. So we have the white list, gray list, and black list. And what does it mean? Okay, the black lists are not allowed for entering the European ports. And finally, we have to mention about the IMO strategy on reduction. I think I am a little bit too long, so just shortly. This strategy is adopted in July 2023 and is completely correlated with the Sustainable Development Goal number 13, so the take urgent action to combat climate change and its impact. Consists of introductions, visions, level of ambition, some checkpoints and guiding principles. We have also described the short, mid, and long term of the greenhouses reduction measures. Then some barriers, supportive actions are described, follow-up actions, and also what is the periodic review of the strategy. And yes, what we have scenarios. So the study was indicated that shipping produce a little bit less than 3% of global anthropogenic greenhouse gases emissions. And this represents between 90 and 130% of emissions recorded in 2008. So will be bigger by 2050. And as we mentioned, some levels of ambitions, so carbon intensity of the ships to decline through the further improvement of the energy efficiency for the new ships, and carbon intensity of international shipping to decline, so the 40% by 2030. So we wanted to reduce by 40% with comparison to 2008 year. Uptake of zero or near zero greenhouse emissions technologies. It could be fuels or energy sources. And the greenhouse emissions from international shipping to reach zero, and the net zero needs to be reached close to 2050. So this is all what I wanted to say. Sorry, I am a little bit too long. Thank you for your attentions, and I'm waiting for any questions. Thank you.
Thank you, Stefan, for your inputs and for the interesting presentation. And does anyone have any questions at the moment?
We have no questions right now. We can move on.
Okay, then I would like to give the word to Professor Marcin Przywarty, also from Maritime University of Szczecin, so he can continue the presentation further. And please, Marcin, go ahead. The floor is yours.
Yeah, now should be better. Thank you, Lisa. We are a little bit behind the schedule, so I'll try to be fast. So good morning, everyone. I'm delighted to welcome you to today's webinar. My name is Marcin Przywarty, and I work at the Department of Marine Traffic Engineering at the Faculty of Navigation of the Maritime University of Szczecin. And it's a pleasure to be here today to discuss an essential topic that is shaping the future of the maritime transport, the European Union legal framework and compliance mechanism aimed at decarbonizing ports and maritime operations. As we all know, climate change poses significant challenges, and the maritime industry must play a crucial role in reducing greenhouse gas emissions. The EU has taken a strong stance through comprehensive regulations and policies, ensuring that the maritime sector aligns with its ambitious climate objectives. Today, I will provide an overview of key regulations, their objectives, and the implications for maritime stakeholders. The EU primary policy to combat the climate change is the European Green Deal, which aims to make Europe the first climate-neutral continent by 2050. A crucial part of this initiative is the Fit for 55 package, introduced in 2021, which aims to cut greenhouse gas emissions by at least 55% by 2030 compared to the 1990 levels. This package is a game changer for multiple sectors, including energy, industry, transport, including maritime transport and buildings. The key objectives of the Fit for 55 package are accelerating emissions reductions, strengthening the EU emissions trading system, enhancing renewable energy deployment, improving energy efficiency, decarbonizing transport, including maritime transport, and ensuring a just transition. And the last main goal, or last key objective, is enhancing carbon border measures. And if we are talking about the maritime transport, one of the most significant regulatory advancements is the inclusion of the maritime transport in the EU ETS system. The revised directive requires ships above 5,000 gross tonnage engaged in intra-EU voyages to participate in the carbon pricing mechanism. Operators must purchase and surrender allowances equivalent to their CO2 emissions, driving the adoption of energy-efficient and low-carbon technologies. Additionally, the FuelEU Maritime Regulation enforces binding targets to reduce the greenhouse gas intensity of fuels used by the ships. From 2025, ship operators must progressively transition to alternative fuels such as hydrogen, ammonia, and biofuels, with incremental targets set for 2030, 40, and 2050. To complement these efforts, the Alternative Fuel Infrastructure Regulation mandates the establishment of shoreside electricity infrastructure in major EU ports by 2030. This will significantly reduce emissions from moored vessels by providing an alternative to fossil fuel-powered auxiliary engines. Beyond direct emissions reduction, the revised trans-European transport network ensures that EU transport infrastructure planning integrates sustainability measures. This includes funding for electrification projects and multimodal transport systems to enhance efficiency in port areas. Next one is the Renewable Energy Directive, which introduced updated requirements for the use of renewable energy in transport, including maritime transport. The directive sets higher targets for renewable energy integration in port operations and incentivize the production and use of renewable maritime fuels. Moreover, the Energy Taxation Directive, which is under revision, seeks to remove tax exemptions for fossil fuels in maritime transport while introducing incentives for low-emission alternatives. This will make sustainable fuels more financially viable and discourage reliance on traditional fossil fuels. To ensure adherence to these regulations, the EU has introduced strict monitoring, reporting, and verification requirements. This obligates shipping companies to report their CO2 emissions, fuel consumptions, and energy efficiency annually. Data collected informs policy adjustments and enforces compliance with decarbonization targets. To conclude, the EU's legal framework for ports decarbonization is a multifaceted system that combines emissions pricing, fuel regulations, infrastructure mandates, and taxation policies to accelerate the transition to climate-neutral maritime transport. These regulations not only establish binding obligations, but also provide clear financial and operational incentives for ports to invest in green technologies, ultimately supporting the EU's goal for achieving net zero emissions by 2050. Just to sum up, here you can see the list of the most important major directives and regulations introduced by the EU. Of course, the list is not finished. There is more, but there are most important directives and regulations introduced by the European Union. While the EU has set ambitious regional targets, global cooperation is also crucial. There are many organizations which publish guidelines and reports to support the transition to sustainable maritime transport. First is the PIANG, which provide technical recommendations for renewable energy and climate adoption in ports. And here you can see the examples of the reports prepared by the PIANG. The next very active organization is DNV, which publish the reports, the guidelines, which are focused on alternative fuels, energy efficiency, and future technologies. And again, here you can see the examples of these reports. There are much more organizations and initiatives such as Zero Emission Port Alliance, European Institute of Innovation and Technology, Environmental Defense Fund, UN Global Compact, and many more, which publish the guidelines, which publish the legal framework, the description of the legal framework, and reports, which helps to change the and to reduce the greenhouse gas emission. Just to conclude, the EU's legal framework for maritime decarbonization is one of the most comprehensive in the world. Through the combination of emissions pricing, fuel regulations, infrastructure mandates, and taxation reforms, the EU is accelerating the transition to a climate-neutral maritime sector. These regulations not only impose binding obligations, but also provide financial initiatives for ports and shipping companies to invest in green technologies. As we move forward, collaboration between policymakers, industries, stakeholders, and international organizations will be a key to ensuring the successful implementation of these measures. Thank you for your attention. I look forward to any questions or discussions you may have.
Thank you, Marcin, for your inputs and information. It was very interesting.
Thank you.
And at the moment, I would like to give the word to Professor Lawrence Henesey from Blekinge Institute of Technology, which will present to us Green Compass for small and medium-sized ports, and it will be like a guide in the green transition. Lawrence, please go ahead. The floor is yours.
Okay, thank you, everyone. Good morning, dzień dobry, labas rytas, guten Morgen, guten Morgen. Ja, vad laudu. Okay, let me just start. Greetings from Sweden. I will go ahead and share my presentation here. And let's see. I believe you can see it, the full screen. Is that correct, everyone?
Yes, everything's
Okay,
fine.
thank you, thank you. So my preparation here is to share with you the highlights, the work we've done under the Digitech Port 2030 project, what is called the Green Compass. It's not just me that's working on this, it's a team. So I'd like to also thank Erica and Vytautas in Lithuania, who have also worked very hard on this project. And I'm really just presenting a lot of the highlights of their work. So remember, everyone, it's a team effort. And what I'd like to share with you is about the work we've done. And this is on the identification indicators for the Green Compass, because we're focusing, as you may right now understand, on small and medium-sized ports. So for us, it was to understand their strategy, also to gain some insight on the management level, what direction they're taking. Also, we investigated and analyzed the port cargo handling services, operations, additional port services that they may have, and the activities of these port services companies. So we engage in a very structured research study. This was conducted through a number of surveys, and for us was to understand for everybody how we could take this information and then try to draft what we call a green port. So from these green ports, we then try to engage in identifying a transformation strategy for them to go from where they are now to be maybe full electric, decarbonized, using alternative fuels and so forth. Also was to understand the management approach to the transformation, help them to understand the development and application of their infrastructure, which, as you may know, for ports and terminals, this is the most expensive and high cost investment is the infrastructure, which can be, of course, the port itself. And then you have the superstructure, which is the equipment, the cranes, the ramps, and so forth. And then as well, we were focusing on the additional services provided by the port in order to help them to define how to be a green port. So in this green transformation strategy, in this slide, we're going to take a deep dive here. And what we came across is that we developed a strategy with a means of packages, trying to understand their goals. And this also is related to the transformation management. And here we were identifying the preparation of the human element, the management, in order to realize these goals. Also, as I mentioned earlier, is about the infrastructure and the superstructure. They're both quite related over here. Is that, as I mentioned, the infrastructure is the actual, I want to say, civil works, and also looking at opportunities for the ports themselves to generate their own power. We're seeing this being done by the big ports and terminals in Europe, such as Rotterdam, with wind turbines and turbines and mills, as well as solar power in many parts. So these big ports are investing into these large projects, but for us, we're very interested to see how these technologies could be tailored and applied into the small, medium-sized ports that characterize many of the ports here in the South Baltic region. And also, we were conducting analysis on the superstructure. So again, from our work, we have around 81 respondents, mostly from Lithuania, Poland, Sweden, Germany, etc. And of course, our sector is the ports and as well shipping, equipment suppliers, and others. And from our key findings is that we did see that ports in general have a basic strategy, but from our project is that we want to help engage with a number of these ports, how they can enhance their strategy and perhaps even be more green. So from the strategic level insights, we see that about 50% have some long-term green strategies. And as mentioned earlier, it's regulations, savings, of course, where you can cut costs, increase productivity, and the public awareness that's driving for ports and terminals to be green. And of course, the cooperation with the authorities is widespread. So with the ports in the that we have been able to contact is that we were relating to their green transformation was to identify how they work in both sea and inland operations, and as well we were not just limited to cargo but also passenger services. So in our work, we're not just focusing on container terminals. We're working with multi-purpose, ro-ro. So it's quite a, I want to say, comprehensive list. So in our evaluation system, and this is the key here now, is that now that we have collected this information, and this was very laborious, and this was undertaken by our colleagues in Poland, primarily Stefan, Jankowski, and Marcin, they were working on this. We then took this data and then we started to evaluate into a structured means. And I will explain to you that we have these 5 points. So we have, of course, the first point where nothing's really achieved. The second one where they have some primary functional elements. The third is that it's getting a bit more advanced with the green transformation. And the port could also maybe have 4 points if they are almost at implementation or actually reducing some of the operational costs in terms of emissions, electricity. And the 5 points is when you are really having an impact on the environment. So this was our point system that we used in evaluating the respondents to our questionnaire. And then we also have as well a weighting coefficient to the main factors. So due to time, obviously this presentation will be made available, so I won't read this to you, but in summarizing is that I just want to explain in that when you're conducting a survey is that we also took the added, I want to say, step in doing the sensitivity analysis, understanding the factors that basically influence our green compass. We also were looking at the strategy and its compliance. We have what's referred to as Fit for 55 recommendations by the European Union, which was covered by my colleagues earlier in this seminar. So in coming back to the development of these green technologies and the attitudes of the customers and, of course, the suppliers, we were, I want to say, measuring this into a structured mathematical formula, and then we use this to develop our compass. And this will help ports as well as maybe possibly with authorities to understand where they sit in terms of being green. So again, we have here these factors 1 through 5. The first one is where you have a port that is preparing the green transformation strategy. The second one is where they have specialists engaged, managers actually focusing on the transformation. The third one is where the infrastructure is prepared. Like, for example, we've met one port where they have prepared with solar panels, but they're not actually utilizing them yet. So they need some help requirements on how to connect these solar power panels to their grid. And then you have the compliance of the equipment with the green transformation, and then finally the customers that are complying with the green transformation requirements. So what I'm sharing you here is the results of for example, of the graphical representation of this survey. And just to remind you what these 5 points are, it's again just showing you. It's on the left-hand side of the screen. You see what 1, 2, 3, 4, and 5 what they identify with. Going on to an example of the green port transformation is that it is a self-assessment, which you have from 1 through 5 points to use for you as a port to identify where you are, where you sit in terms of becoming green, and then as well, it helps you to identify where the if I may say, the easy or the low-hanging fruit where you can focus on in trying to be green. And I have as well some examples. For example, for many ports and terminals, it's the use of alternative fuels. This is a very interesting area. For example, going electric. We also have underscored that there is some issues as well with the grid. Can the local authority be able to connect with the grid? Also, the issue of hydrogen LNG came about, and that many terminals, they find this to be quite expensive. So, and as well, we also looked at the port customers. So a port is not just a pier; it is a functioning node, and where it is working with other modes of transport. So, with the rail, with the trucks, being able to provide I want to say services such as, for example, charging for the vehicles, maybe as well LNG, like we see in the big ports, offering LNG hydrogen for the trucks coming off the road. So in summarizing is that we have this weighting coefficient, as I mentioned, and we look at a number of the ports, and we analyze a sample. So this is our equation here that is prepared, and you can see that we are taking the added steps in evaluating the green compass to ensure that it's credible. And then over here in this slide, we are applying our compass to the ports. So, for example, on the equipment and the processes, how they're being serviced by the operational hour, the energy or fuel being used for each operation or equipment, the consumption, the amount of gas or petrol used, amount of electricity, number of passengers served, if they're being served, and of course, processing of cargo in tons or containers, however that is being, whatever commodities being handled at the port. So, from the insights, we could see that the key actions are from the management level: electrification, IT systems, energy optimization. Barriers, unfortunately, right now for some of the ports and terminals are low return on the investment. There are some funding gaps, and as well, we find a lot is staff limitations. Unfortunately, small, medium-sized ports in the Baltic don't have the resources like the large ports and terminals like Hamburg and Rotterdam, where they have staff engineers, actual electricians, or electrical department that is a part of the port. Some of the operational level insights that we were able to gather was the adoption of renewables. More and more, there's an interest in electric vehicles, green infrastructure, and as well monitoring methods. The use of KPIs, key performance indicators, also looking at the inventory of the GHG and IT systems to help them with identifying how they can improve their operations from an environmental standpoint. So the conclusions, everyone, is that we have developed this methodology where we filter this self-assessment, because let's be honest, when we are self-assessing ourselves, we need to be honest with ourselves. So this is a way of being objective in the self-assessment. It's also, we feel that from this green compass, it is an effective work for the small, medium-sized ports here in the South Baltic to help them identify where they are and where they should focus in terms of becoming green. Also, from the conclusions is that we see that the methodology helps in calculating the main emissions generated by the small, medium-sized ports. Also, point 4 is that the estimated main emissions, we can see that the impact to the environment, but it's also, we see that there's also possible ways to reduce the impact. And then number 5 is on the basis of the developed methodology. We are right now in the midst of calculating a simulation program. We're going to be using this, and it's going to be called a energy twin. So we're really excited to be rolling this out in our pilots that we are right now currently working on. So hopefully you'll be able to join us in our next seminar where we'll present some of our findings and results. So for everyone, thank you for your attention. I do welcome questions and comments because this is not a monologue. This is supposed to be a dialogue, and very happy to entertain any questions that you may have. So everyone, thank you.
Thank you, Lawrence, for your inputs and information. It was a very interesting presentation in terms of the Green Compass. Thank you very much. And now I would like to ask if someone has a question. Andrzej, maybe you can help us.
I'm checking. Sadly, we have no questions at this point. I can just add that we will be reaching out to our participants via email. So if you have any questions that come up later on, you can ask them then.
Okay.
We will be in touch with them.
Okay.
I have a question for the audience. How many are ports or terminal operators? Anyone a port or a terminal that would like to consider working with us on a pilot?
Maybe Andrzej can share if we have how many of them we have at the moment.
I cannot see it at this time, but we can add it to the follow-up email and we can find out how many would be interested in cooperation with the project.
Okay.
Yeah, sure, because it's very important for our project, and we're waiting for any collaboration, any participation in our project, and we're open to collaborate in the future. And yes, from my side, I would like to thank everyone who participated in today's session, my colleagues from Maritime University of Szczecin, Professors Stefan Jankowski and Marcin Przywarty. Thank you for your inputs and presentations. And of course, for Professor Lawrence Henesey from Blekinge University. Yes, and I'm open to any questions as well as a lead partner, as a project manager of Digitech Port 2030. And I hope we will keep in touch, and looking forward for your comments and new ideas. If no one has any questions at the moment, I would suggest...
Perhaps a comment is that what we have to get across is that we often hear about the big ports and terminals. They have large budgets like Rotterdam, Antwerp, London,
Hamburg.
Hamburg. And then you also have the operators. There has been a big push with operators significantly after COVID, where you have the shipping lines. They made a lot of money with the shipping, with rates at $25,000 US in moving containers from China to Europe or from China to America. So this provided them a lot of money to invest in ports and terminals, to modernize them, automate them. And now we're seeing more and more the use of electrification in automating the ports and terminals. Now, this is great for the big, large, I want to say, big, large container terminals and also some of the large bulk terminals. But what is of interest is how we can take that technology, take that know-how, and tailor it to the small and medium-sized ports and terminals. Just in Europe alone, we have over 1,400 ports. So obviously not all 1,400 would be a main port or a gateway to Chinese or North American terminals. So from our project, what I'm hoping is that for the audience, they can see is that we are making some impact in trying to understand what technologies, what processes, what we can do in order to tailor the existing technologies and process and bring it down to small ports and medium-sized ports and terminals to make them green. And of course, at the bottom line is that they need to have a return. Obviously, you don't want to invest into a technology that is, it may be cutting edge, but it's actually bleeding edge. It's bleeding you in terms of cost. you're not making money. It's a painful solution because it's not meeting the bottom line. So I hope for the audience that they can see from our project and from the presentations is that this endeavor, this initiative that's been funded by the EU, that it does have some promise. And again, we are working on 5 pilots, and we do hope to have a couple more. So this is a bit of a marketing here, is that we do like to see if we can also work with other ports and terminals within the South Baltic region.
Thank you, Lawrence. I totally agree with you. And I would like to add, yes, as you said, big ports such as Hamburg, Rotterdam, they have a lot of investments, a lot of support from the government. And at the same time, small and medium-sized ports need a lot of support, a lot of help to promote themselves and to get more attention, let's say. And this is why we are today here, to promote our project and attract more collaborations to that. And hopefully in the future, we will have very positive outcomes as a result of this project. Thank you very much for highlighting this inputs, these ideas. They're very insightful. And does someone have any questions right now, maybe, from the audience? Andrzej? Nothing, or?
Sorry, I was writing in a second. No, we didn't have any questions. There was only a request whether we could share potentially the presentations after the webinar.
Okay.
I think this would be possible.
Only if you ask a question.
All right. We will be sending out a summary email to everyone that's registered, and I will also post Motu's email in the chat in a second. So if you have any questions, you can also post them via email. We will be happy to answer them all.
So the listeners, they can always follow up and receive any presentations, any comments from us if they have one. And yes, thank you very much all for participating in the session. Thank you for Professor Lawrence, Professors Stefan Jankowski and Marcin Przywarty. Thank you very much, and hopefully I will see you all in the next session, which we will be holding very, very soon. Yeah. Does anyone would like to add something or nothing? Stefan?
No. Everything's okay. Great.
Okay. Thank you
we
very
much.
We
are waiting for questions, by the way.
Yeah, I think it's probably Thursday. Everybody's waiting tomorrow.
Okay.
Thank you, everyone.
Thank you, everyone, and see you on the next session. Thank you. Have a nice day.
Thank you. Bye-bye.
See you. Bye.
Bye-bye. See